Hello everyone. So today we are going to do a presentation on von Neumann architecture. So these are the topics that we are going to discuss today. The first one is what is an architecture, and the second topic is the types of computer architectures, and the third one is introduction to von Neumann architecture, and the fourth one is components of von Neumann model, and the fifth one is advantages of von Neumann model, and the sixth one is disadvantages of the von Neumann model, and the seventh one is the alternative architectures, and we will conclude the presentation with the summary. So guys, I'm Yuresh Fernando and my index number is 216032J, and today I will explain the topics what is an architecture and the types of computer architectures. So the first topic is what is an architecture. So the complex or carefully designed structure of something is referred to as architecture. In computer engineering, computer architecture is a set of rules and methods that describe the functionality, organization, and implementation of computer systems. The architecture of a system refers to a structure in terms of separately specified components of that system and their relationships. So next, I will explain my second topic, which is the types of computer architectures. So there are two major types of computer architectures. The first one is the fixed program computers, and the second one is the stored program computers. Fixed program computers, their function is very specific and they couldn't be programmed. Example, calculators. Stored program computers, these can be programmed to carry out many different tasks. Applications are stored on them, hence the name. And some examples for stored program computers are PCs and mobile phones. Next, I will ask Tikshana to continue from the presentation. Tikshana.
Thank you, Uresh. I will continue from here. So my name is Tikshana Madhuhansa. My index number is 2216008R. Okay, everyone, welcome to my part, that introduction about von Neumann architecture. Uh, the von Neumann architecture, also known as the von Neumann model or Princeton architecture, is a computer architecture based on a 1945 description by John von Neumann and by others. So the modern computers are based on a sorted program concept introduced by John von Neumann. In this sorted program concept, programs and data are stored in a separate storage until called memories and treat the some say. The novel idea meant that the computer built with this architecture would be much easier to reprogram. The basic structure of von Neumann architecture like this. So there are input and output devices that connected with CPU, that central processing unit. After that, I will come to my next topic, that characteristics of von Neumann architecture. Process data and instructions for data should be stored in memory. It include first one CPU, the central processing unit. Under the central processing unit, there are ALU, arithmetic and logic unit, and control unit. Secondly, storage, primary memory formed by RAM and ROM, which is fast to access, and also cache memory and registers. Third one is input and output devices. So this is end of my part. I introduced what is the von Neumann architecture and characteristics of von Neumann architecture. I invite our next member. Over to you, Nitula. Thank you.
Thank you, Deekshana. I will continue from here. My name is Nitul Nandil. My index number is 216840. My topic is components of the von Neumann model. There are three main components consisting the von Neumann architecture. First one is the central processing unit. Second one is the main memory units, and the third one is the input-output devices. First we see what is the control processing unit. It has two components. First one is the control unit. A control unit handles all processor control signals. It detects all input and output flow, sets code for introduction, and controls how data moves around system. Next one is the arithmetic and logic unit. The arithmetic logic unit is that part of the CPU that handles all the calculations the CPU may need, example addition, subtraction, comparisons, like that. It performs logical operations, bit shifting operations, and arithmetic operations. Now you can see the basic CPU structure. This is the memory, and this is the ALU, arithmetic logic unit, PC count, program counter, IR, accumulator, and this is the general purpose register and IO buses. This arrow shows how data is transferred. Now I will explain the registers. These are some examples for registers. First one is the accumulator. It stores the result of the calculation made by ALU. Next one is the program counter. It keeps track of the memory location of the next instruction to be dealt with. The program counter then passes this next address to memory address register. Third one is the memory address register. It stores the memory location of instruction that need to be fetched from memory or stored into memory. Fourth one is the memory data register. It stores instruction fetched from memory or any data that is to be transferred to and stored in memory. Fifth one is the current instruction register. It stores the most recently fetched instruction while it is waiting to be called and executed. Sixth one is the instruction buffer register. The instruction that is not to be executed immediately is placed in the instruction buffer register. Okay, yeah, that's all about the memory registers. Now Ramesh will explain the next slide.
Thank you, Nitula. I will explain input and output devices and buses. First one, program input and output devices. Program or data is reading into main memory from the input devices or secondary storage under the control of CPU input instruction. Output devices are used to output the information from a computer. If some results are evaluated by computer and it is stored in the computer, then with the help of output devices, we can present them to the user. Okay, you can see the input and output devices in here. Okay, next one. Okay, now I will explain buses. Data is transmitted from one part of a computer to another, connecting all major internal components to the CPU and memory. By the mean of buses, three types of buses. First one is data buses, is carrier data among the memory unit, the IO devices, and the processor. Second one is address bar, is carrier the address of data, not the actual data between memory and processor. Third one is control buses, is carrier control command from the CPU and state a single from other devices in order to control and coordinate all the activities within the computer. Okay, you can see the system buses, overview of system buses, CPU, memory, input and output devices, then three types of buses: control buses, address buses, and data buses. Then these arrows show how data is transferred. Uh, okay, that's all about the buses. Next, Ravindu will continue from here. Thank you.
Thank you, Rumesh. I will continue from here. So my name is Ravid Dulshan. My index number is 216030C. Today I am explaining of the benefits of the von Neumann architecture. That's all about the here are some advantages of the von Neumann architecture. First one is control unit retrieves data and instruction in the same manner from one memory. Design and development of the control unit is simplified, cheaper, and faster. Second one is data from input or output devices and from memory are retrieved in the same manner. Third one is organization of memory is done by programmers, which allows them to utilize the memory's whole capacity. That's all about the advantage of the von Neumann architecture. Okay, now Dilshan will continue from here.
Thank you, Ramidu. I will continue from here. I am a Dilshan Randima. My index number 2161, Note 5L. I will explain disadvantages of the von Neumann model. Whatever we do enhance performance, we cannot get away from the fact that instruction can only be done one at a time and can only be carried out sequentially. Both of these factors hold back the components on the CPU. This is commonly referred to as the von Neumann bottleneck. We can provide a von Neumann processor with more cache, more RAM, or faster components, but if original gains are to be made in CPU performance, then an infections need to take place of CPU configurations. This architecture is very important and this used in our PC and even in supercomputer. Here are some other disadvantages of the von Neumann architecture. First one, parallel implementations of program is not allowed due to sequential instruction processing. Second one, von Neumann bottleneck instruction can only be carried out one at a time and sequentially. Third one, it's of an instruction being in rewriting due to an error in the program. Thank you. Now I would like to invite Dinesh.
Thank you, Dilshan. I will for another. Thank you, Dilshan. I will continue it by here. I will explain an alternative architecture for von Neumann architecture. Here is the Harvard alternative architecture. In a normal computer that follows von Neumann architecture, instructions and data both are stored in same memory. So, same buses are used to fetch instructions and data. This means the CPU cannot do both things together. Read the instruction and read and write data. Harvard architecture is the computer architecture that contains separate storage and separate buses, single part, for instructions and data. It was basically developed to overcome the bottleneck of von Neumann architecture. The main advantage of having separate buses for instructions and data is that the CPU can access instructions and read and write data at the same time. The advantage of Harvard architecture. Harvard architecture has two separate buses for instructions and data. Hence, the CPU can access instructions and read-write data at the same time. This is the major advantage of Harvard architecture. In practice, modified Harvard architecture is used where we have to separate cache, data, and instruction. This is the common and used in x86 and ARM processors. Here is the structure of Harvard architecture. These are the components of Harvard architecture. First one is main memory system. Second one is optional registers, program counters, arithmetic and logic unit, control unit, and input-output system. So, thank you. The rest of our presentation will be continued by Uresh.
Thank you, Dinesh. I will take it from here. This is the last part of our presentation, which is the summary. Von Neumann architecture is based on a stored program concept, and it consists of three main components. The first one is I/O devices, and the second one is memory registers, and the third one is central processing unit. Von Neumann architecture is the design upon which many general purpose computers are based. The key elements of von Neumann architecture are data and instructions are both stored as binary digits. Data and instructions are both stored in primary storage, and instructions are fetched from memory one at a time and in order, which means serial processing. The processor decodes and executes an instruction before cycling around to fetch the next instruction. The cycle continues until no more instructions are available. So here is our team, right? I'm Yuresh, the team leader, and here are the other team members: Rumesh, Dinesh, Ravindu, Teekshana, Nitula, and Dilshan. So thank you for joining with us.